I should mention that welcome Darren, this particular quiz is, it's not a real quiz, it's mostly just practice. Do these converge or diverge? Tell me why. So I guess we could do this since everyone's got it in front of them. We can do it before we do the homework, talking about the homework, and then we'll get to the homework, and then we'll talk about what's on the exam. So take a few minutes, work through this, and for the people who are watching, I'll adjust my attendance here in just a minute, and for the people who are watching from home, I'll slowly scroll through. And I see a typo that's going to bother me. I don't know if it bothers you. This right here on number 9. There we go. Should have a close parenthesis. Oh, so by the way, when I say explain, you don't have to give me all the details. Just tell me what you're doing. Like if it's a p series, you can just say p series. And tell me what the p-value is, of course. Or if it's geometric. If you're using a comparison test, tell me what you're doing. Alternate, just tell me what you're doing basically for each one. You don't have to get all detail-y on me. Okay. Here we go. Okay. All right, let me get her down here. Oh, and if you weren't here earlier when other people started, since this is I'm not collecting this, so you can work with a friend if it helps you. It's always good to study with a friend, so you should be doing that anyway. Exam you got to do on your own, but you can compare notes. I'll get the answers here in a minute. How we doing? Working. Nice. Curious. All's done. Very good. See, getting her done. Just curious to see. Oh, nice color. That's going to be hard to read if you use that on your scene. Yeah, I guess it gives you a challenge. It's good. Good to get it done. Yeah, what's that? Mm-hmm. Oh, okay. When you do this, this is the limit comparison test. Then if the limit is anything other than 0 or infinity, then that links them. So whatever happens to this one is going to happen to that one. Yeah, very good. Good job. Wow, you guys are done. Still working. Almost done. Well done. All right. You could make friends with Christian over here, but I mean, I know you like to work alone. It's fine. Keep it up. You're doing a great job. So. Is it looking okay over here? Look at that. You're all done. Incredible. No. Well, there's a few that are still working on a couple of them. Good job. Well done. I see you've got your list of questions. Good job. Just checking to see how people are doing. Excellent. Oh, wait a minute. What's going on? I don't Clash Royale. You gotta get it right.
Did you see the update? They ruined it.
I know, they took away all the goodies. Oh, now you're.
Yeah, it's our map.
Okay. Oh, let's see.
These are our campsites.
Nice. Okay, right through the middle of Columbus. You get to go home. Very nice. Wow, that's impressive.
It'll be fun.
Very nice. Oh, I'm sure it will. Especially, how many people are going?
I don't know yet. 4 of us, but there's an 80-year-old lunatic coach. His name's Phil Frost.
Oh, Philip Frost. Yeah. Okay.
So he might join us.
Well, but he has an e-bike.
He does.
So
I wouldn't let him use that on the trip. I'd make him use one of his road bikes.
No. He's 80. Let him use his e-bike. Come on.
He will outbike me on a regular bike.
But he's 80. You gotta let him use his e-bike.
Have you gone on any bike rides with him?
I have not.
He climbs up hills like that steep, no problem.
That's because he's got an e-bike.
This was before he had his e-bike.
Oh, I see. Okay. Yeah. Well, he would. Yeah. I'm sure he would be a great person to bring with you. You could load him up with all the goods, like all the food. You have his panniers are chock full of stuff. Yeah. Oh, you guys are done. You're still working, but you're thinking. And she's going to teach you about these. Wait, you haven't done that one. But you did this one. This is almost the same. I know, that extra 5 in the bottom. Just get rid of the extra 5. That's all you got to do. Yeah. Oh, yeah, it's okay. That's just like 5 times 5 to the n. Isn't that what the +1 does? It's just an extra factor of 5. So you can just sort of factor it out. And then it looks just like that one. So you're done. These guys are done. These guys are done. You're done. Okay. All right, so most people are done. So I don't want to bore the people who are done. So if you aren't done, you can either put your fingers in your ears, or you can just sort of jot down the answers and then loop back around and on, during the next day or so, make sure that you can do the ones that you didn't quite get to. So let me go over what I've got. And if I've got them wrong, just complain, because I did this in like 2 minutes. I just was like, converge, diverge, converge. And so if I got one of them wrong, I can own that. So let's take a look at the first one. The first one, P series, radical 5. I didn't even do this on a calculator. I probably should have. Let me grab a calculator. Radical 5 is like 3 or 4 or something like that. And then radical 3 is 1.7. So I think that's less than 1, isn't it? Let me check. Radical 5 is 2.2. Yeah, for sure. So 2.23 minus 1.73 is 0.5. So that's less than, it's a p series. The power is less than 1. So this thing diverges. Hopefully everyone got that one. Yeah, I've got, I don't know, I'm fond of doing stuff like this. Like I might have in here, how about this one? Just to make it fun, we could do 1 over n to the pi minus e, just for fun. Anyway, that one diverges as well. Okay, so let's do this one. So it's also a p series. But here, you just need to know what this means. So hopefully you all know that when you do the cube root, that's the same as a 1/3 power. So the power here is 8/3, which is bigger than 1, so this thing converges. So far, so good. Okay, so the next one, yeah, I didn't write down my work, but the r here is 2/5. It's geometric. Here's another way of writing this, 2 to the n over 5 times 5 to the n. And so this becomes the sum of 1/5 times 2/5 to the n. So a little bit of algebra involved there, but the important thing here is that the r is 2/5. I kind of was going minimalistic on you. So if you want to be minimalistic with me, you could always just leave this stuff out. Here, just a minute. Let me change this to there. So can I make that more bright? Maybe not. Sorry, I'm trying to match. There, Ben has a marker or a pen that's really faint. There, does that look about like what you have? It's pretty close. Okay, good. Yeah, just trying to make you happy. There, now you can hardly read it. But anyway, yeah, don't use that pen on Friday. Well, if you do, I'll just get a bright light. Okay, but anyway, the red there is all you really need for this. So that's, yeah, let's take a look at the next one. Next one, hopefully everyone got right. Geometric, super easy. 9/5. It's all written like a geometric series. The r is 9/5, so this thing diverges. So yeah, this is sort of, when you get to the test, I have the test. It's similar to the practice test, but there are a few problems where I say, do whatever you want. Tell me if they converge or diverge. And this is the sort of thing I'm looking for. Is just tell me what you're doing and tell me if it diverges or converges. Okay, so let's do number 5. 5 was kind of fun. You could either use a limit comparison or a direct comparison. Fortunately for us, the direct comparison works nicely with this one because when you get rid of the n and the 1, it makes the denominator bigger, or no, smaller, which makes the fraction bigger. So this will be less than this, so this thing converges. And if you want to, you can say that's a p series, but I think I'm okay with you. This is kind of like the bare minimum. If I see this on your paper, I'm going to do something like this. Here, just like there it is. Check it off. There, you're done. So I go through page at a time and I just check everyone's. So far, so good. No questions about 1 through 5. Those were the easy ones. Let's take a look at the hard ones. Okay, number 6. Okay, so this one, I used a limit comparison test, and I was comparing to 2/3 to the n, because I thought that was sort of similar. I think you might be able to figure out a way to use a direct comparison, but the problem here is that minus, right? It doesn't really lend itself well to a direct comparison. But this worked out just fine because when I did this limit, a little bit of algebra, I got 1. So separate this into 2 fractions. 1 minus n over 3 to the n, which the limit is just 1. I know I didn't show you all my work. You could say L'Hopital's rule if you want, but this is sort of the minimum. So that one converges. Number 7, another limit comparison. Excuse me. So this one, yeah, I think well, you probably could have done a direct comparison with this, but I just was like, it's a limit comparison, easy limit comparison. And because 1 over n, the harmonic series diverges, this will diverge. By the way, here, direct comparison. Let's do it real quick just so you can see that it does work. So 2 plus 3n over, so this is alternate version. So that happens to be less than, or no, bigger. We're going bigger. That happens to be bigger than this. And that happens to be bigger than this. Sorry, that's an n squared. As long as n is bigger than 3, n squared will be bigger than 9, which makes this a smaller fraction. And then you can say that that is equal to 1 over n. so anyway, so this thing is bigger than 1 over n, which means since 1 over n diverges, that thing will also diverge. So alternate, either you can do direct comparison if you want to, or a limit comparison. I find that I generally will default to a limit comparison only because then I don't have to worry about those nasty inequalities and making sure, because if you write down something that is false, I will mark it wrong. So for example, if you do this, here, let me just show you. 3n over 2n squared plus 9 is greater than 3n over 2n squared. That is false. And I will be like minus 100 points. No, I won't do that. I'll probably do like this. But yeah, I understand what you're trying to do, but this is not true. So don't tell me any lies and I will be happy. Let's get rid of that false statement. So that's why I say that I default to the limit, because the limit is generally safer. You don't have the inequalities are hard. They are hard to get them straight. I mean, you look at the gymnastics I had to do up there. Okay, let's move on. Number 8. Number 8, oh, this one is divergent because of just a straight limit. If you just do the limit of the term, I know you got that weird sign of n there, but it doesn't matter. If I do the limit as n approaches infinity of this thing, I get 1, which, you might say, how do you get 1? Okay, we could do L'Hopital's rule. Can I do L'Hopital? Or no, let's do it this way. Here, so I'll show my work. So this is going to be the limit as n approaches infinity of, just a minute, this is going to bother me. Why is this like this? Just a sec. There. Okay. It's too fat. My marker was too fat. Okay, so this is going to be this. Okay, there we go. And so hopefully you recognize that this sine of n over n plus 1, that will divert, or sorry, not diverge. The limit of that is 0 because you have numbers that are getting bigger and bigger and bigger. When n gets bigger, this gets bigger. That never gets big. That stays between -1 and +1. So the limit of this is 0. And the limit of this one, of course, is 1. 1 plus 0. And so that's why this is 1. But anyway, since the limit of the term is non-zero, this diverges. So this is that little thing that I snuck in there. It was actually in the very first, it was in section 11.2, but we just didn't do it in class for some reason. But this is that limit of the term is non-zero. So for sure you're diverging. Number 9 is, hopefully you recognize this, has a -1 to the n. So that is a alternating series. So here the alternating series test. And I kind of cheated. I will show you where. But if you write something like this, I will mark it correct. I'll be like, hey, that's beautiful. But here, so here's how I do the alternating series test, just to remind you. I first of all take the positive stuff, so I know it's all positive, and I do the limit as n approaches infinity. If that is 0, I have to double check, does this thing decrease? It's got to decrease. I'm going to show you why in just a minute, because someone asked me this. Can't you just check this? No. Yes, I have to say it decreases. So how do I know this is decreasing? Well, I'm just going to wave my hands here, but the way I would check is one way to check is to do the derivative, quotient rule, and then double check to make sure that the slope is always negative. It's such a pain. I don't want to do it. But also, you could graph this, and that's not really proving that it decreases, but you'll find that you're dealing with something that slopes downward. So anyway, well, I'll show you an example where if you don't have this decreasing, it's not going to converge, or sometimes. Okay, last one, and then we'll show you my little thing, and then we'll go on to the other stuff. So this one, what in the world is this? Well, this one is also an alternating series. It's just cloaked. It's hard to see that it's alternating. If I rewrite it like this, -2 is the same as -1 times 2. Now it's clearly an alternating series. So you take that and you do the alternating series test, which is to do the limit. So the limit of that stuff is 0. And I don't think I even wrote it down, which I should have at least said something like this. Yes, I didn't even write it down. So here, 2 to the n over 3 to the n plus n cubed is going to be decreasing. Maybe we should see why. This one is going to be easier than the previous one. So yeah, let's, yeah, okay, I'll do it. I'll do this one. I won't do the previous one. Let me actually prove that this one decreases. You can graph it, and when you graph this, you're going to see this thing that just decreases and levels off at 0. But let's actually show that this decreases. I'll do my job. Okay, so we're going to do the derivative. So we're going to call this f. So f prime is going to be low d high. So that's going to be the natural log of 2 times 2 to the n times the bottom minus high d low 2 to the n times natural log of 3 times 3 to the n plus 3n squared. Good enough. All over low squared, 3n plus n cubed. So notice I just did the derivative. I know it's painful, but bear with me for just a sec. I have the natural log. I'm going to do some simplification, really quick simplification, times 2 to the n, times 6 to the n. 2 times 3 is 6, plus natural log of 2 times 2 to the n times n cubed minus natural log of 3 times 2 to the n. Sorry, I had to think for a minute there. 3n squared all over, oh, this should be squared. 3n plus n cubed. Okay, so without getting into the gory details, let me just point out that natural log of 3 is bigger than natural log of 2, correct? Yes, it is. So this will be negative. You'll have negative times 6 to the n. Now, when you compare these two things, notice that I can factor out the 2 to the n. What I'm left with is natural log of 2. Maybe I should write that down. Well, I won't. Natural log of 2 times n cubed over here, and then minus natural log of 3 times 3n squared over here. But that could be positive, but it will never be as big as 6 to the n. So you have 2 to the n over here, which is smaller than 6 to the n. So this could be positive, but it won't be as positive as this. And so this wins. And so this thing it's going to be negative. And so that will be less than 0, less than 0. So this thing definitely decreases. So that's the sort of thing. On the test, if you want to just sort of say, hey, look, you graphed it, whatever, you can say it's decreasing. I'm fine with that. Because what am I going to do? I'm not going to give you one that doesn't decrease, am I? Okay, so some of you are wondering, or maybe one of you is wondering, is what happens if you don't decrease? Well, let's take a look at this series. This particular series has alternating terms. You might say, how are they alternating? Let me show you the terms. The terms look like this. So I've got, if you plug in n equals 2, you'll get positive 3/4. When you plug in n equals 3, you get negative 1/9, then plus 7/16, minus 1/25, and so on and so forth. So what's wrong with this? Well, let's see what's wrong with it. Let me do this. The limit, let's do this. The limit, no. Yeah, we can do this. The limit as n approaches infinity of that stuff, we're going to just call this, I'll just call it a sub n because I don't know how to, I mean, I can separate out the negatives and the positives, but you can see that the limit is going to be 0. So I don't know if you can see this, but notice that the positive terms are all getting smaller. The negative terms are also getting closer to 0. So 11/36. The next one would be, let's see, 2 times 8, 16 minus 1, 15 over 64. So that's the next positive term and so on. So you have that situation. However, the problem with this thing is that the sum, this thing actually diverges. So the limit is 0, but the terms are not decreasing. So if you look at this, you have positive 3/4. Then if you take, so 3/4, 1/9 is smaller than 3/4, then this is bigger, then smaller, bigger, smaller, bigger, smaller. So you have this situation where the terms they are not decreasing. And then if you want to know why do I know this doesn't converge? Well, yeah, I should say that not decreasing doesn't indicate that you're going to diverge, but in this case you do. I just wanted to show you an example where the series actually diverges. So here's how I'm going to do this, is I'm going to take 2 terms, I'm going to group these together like this, so like that, and then compute the sum of those 2 terms. So here's how this is going to shake out in terms of n. You notice the even term is going to be like this. Sorry, I need to change this to, whoops. This thing is going to bother me. There we go, because it's so skinny. It's hard for me to read. Okay, so here's the even term. The even term ends up being 2 times n minus 1 over n squared. So when n is even, you get, -1 plus 1, which is 2 times n minus 1 over n squared. And then when n is odd, you get 1 plus -1, which is 0 times n minus 1 over n squared. So when n is odd, the very next term is going to be plus -1 over n plus 1 squared. So anyway, that's what this is sort of looking like. So one way to look at this is that we're adding together, you're adding together a bunch of things, and I'm just going to group them like this, successive terms. Yeah, my indices here shouldn't be n, but we'll forgive that for a minute. But if you take a look at this and add these together, check out what happens. You end up with 2n minus 1 times n plus 1. I know this is a bit tedious. Minus n squared over n squared. Now let's get rid of this for a sec. N plus 1 squared. And that's going to equal 2. Okay. Okay, I'll write it out. I'm reticent to write out all of this, but you probably don't care. So let's just do it this way. 2n squared cubed, 2n cubed plus stuff. What I mean by that is it's lower powers. Then you've got the minus n squared. But the biggest power here is n cubed. You have that n times this n squared. And on the bottom, I have n to the 4th plus a bunch of stuff. Okay. Okay, so the important thing to note here, though, is that so this is going to be 2n cubed plus some stuff over n to the 4th plus some stuff. And so hopefully you recognize that if we did a limit comparison of this with 1 over n, those two, you're going to get the limit will be finite, like 2 or something, and this thing diverges because this diverges. So that's why this thing diverges. So I just wanted to show you an example where it does diverge, even though we have an alternating series. The limit is 0, but the problem here is that it's non-decreasing. So when it doesn't decrease alternating series, you don't know. The question, is I don't know, don't know. So you have to do something else. So this is kind of contrived. I don't know why I needed to write that word, but there it is. So let's move on from that and go on to the other stuff. Homework for today. Homework. So you had homework for today. Let me go find my homework. Here it is. So what sorts of issues? Were there any of these that you couldn't figure out and that we need to do? I see we've got Ryan. What do you got? 28. I assigned it. Oh, yeah, there it is. Number 28. Very nice. Wait, 28? What's wrong with 28? This one?
Yeah.
What does it say? Find the sum. Why am I having to find a sum of this series? Yeah, I don't know why it's asking me to find a sum. Oh, I can do this. Actually, I can do this. Okay, yeah, let's do it. Yeah, okay. Let me just go down to the bottom though. 1 over n times n plus 3. Yeah, let's do it. Okay. I was thinking that these were more, does this start at 1 or 0? 1 has to start at 1. I was thinking these were more just checking to see if they converge. This one definitely converges, doesn't it? You can use either a direct comparison or a limit comparison to show that this converges. So this does converge, but the question is, what does it converge to? And so to do that, what we're going to do is we're going to write down the partial fractions expansion of this thing. So this is going to equal a over n plus b over n plus 3. So you know the drill. You can do this. It's not that hard. And when you get done, I believe that what we're going to get, give me a sec here, 1 and 1, 1/3, 1/3. Okay, so what we're going to get is you're going to get a is equal to 1/3 and b is equal to negative 1/3. I know I just did that in my head, but it's not that hard when you have numbers like this. So you'll, if you do enough partial fractions, I'm just trying to skip the hard stuff and get to skip this and get to the good stuff. Okay, so there's my a and my b. So in other words, this particular sum looks like this: 1/3 times 1 over n minus 1 over n plus 3. I know I just factored out the 1/3, so technically it's 1/3 over n minus 1/3 over n plus 3, but you can factor out the 1/3. It's easy enough. So far, anyone losing their mind? I know you're like, well, I lost it a couple of days ago, so. Okay, so we're in good shape, sort of, maybe, hopefully. Okay, so the next step is to start writing partial sums and looking for a pattern. So let's do the partial sums. So remember, a partial sum is going to be what you get when you stop after however many terms that you have here. So that's the first partial sum. Whoop-de-doo. Okay, let's do the second partial sum. 1/3 times 1 over 1 minus 1 over 4 plus 1 over 2. Now let's do it this way. Minus 1 over 5. And that's it. So what I've done there is I thought to myself, I don't have to write 1/3 all these times. Let's just write it once. And so this is what you get when you plug 1 in to that. And this is what you get when you plug 2 into that. Everyone's happy. Okay, it's going to take me a minute till we see the pattern. So you keep doing this until you start seeing a pattern. 1 over 1 minus 1/4 plus 1/2 minus 1/5 plus 1/3 minus 1/6. Still no pattern. Well, here's where the fun starts. 1, 1, 1/4. Give me a sec. I know it seems tedious. In fact, I am feeling like this is really boring. So I can't imagine how you feel. Here's where things get fun. Let me see, can I make this, come on, buddy. Can I get this to move? I can't get this to move. Sorry, I've got got problems with my thing. Okay, but check it out. 1/4 and 1/4 cancel. Isn't that cool? Okay, well, let's keep going and see if things get even better. Okay, so S5, 1/3, 1/1, 1/4, 1/2, minus 1/5, 1/3, 1/6, 1/4, 1/7. Sorry, it's just this one is a little longer than some of these are. Okay, so there we go. I think we had one or two of these like this a long time ago. So this is kind of a little bit of a reminder, or maybe it's like, oh yeah, that's what we did, or maybe we never did. But notice that the 1/4 cancels and the 1/5 cancels. Well, I think you can see the pattern here. I'm not gonna write down any, well, I'm gonna write down one more, and that's this one, just to show you how this works. Let's do S10. And I know you're thinking, no, don't worry. So here's what I'll do. 1/1 minus 1/4. I'm not gonna write it all down. I'm gonna put some ellipses here in just a minute. 1/3 minus 1/6. And then I'm gonna put some dots. And then let's see, I'm going to end at 1/10. So let me just get the next two, maybe three. Okay, so the last one is going to be 1/10 minus 1/13, then 1/9 minus 1/12, and then 1/8 minus 1/11. Now here's the cool thing about this, is that if you notice the pattern here, the 1/4, that 1/4 will cancel with this 1/4. This 1/5 cancels with this 1/5. So lots of stuff is going to cancel. So let's see if I can figure out what cancels. This 1/4 will cancel with something over here in the ellipses, actually the very next term. The 1/5 is going to cancel with something over there. The 1/6 also will cancel. Now, what about these last three terms? Well, in the last three terms, the 1/8 will cancel. You might say, well, which one will it cancel with? It'll cancel with, over here, 1/5. Actually, it's right there. 1/5 minus 1/8. That 1/8 gets canceled. The 1/9 is going to get canceled, and the 1/10 will get canceled. And actually, everything in between, I probably should have put at least one more term. In fact, I will right now, just so that you don't, here, let's get rid of that. And we'll put one more term in here. So this will be 1/4 minus 1/7. Everything in between those are going to be in the situation where both terms get canceled. So all that's going to survive all of this canceling are the first three positives and the last three negatives. So here I can write a formula down, and that is this, that S sub n will always just be 1/3 times 1/1 plus 1/2 plus 1/3. Those will always, they never get canceled. And then at the end, you'll have minus 1/n plus 1 minus 1/n plus 2, 1/n plus 3. Check it out. This is true, like when you had S5, you have 1/8, 1/7, and 1/6. S10, we had 1/13, 1/12, and 1/11. So that's my S. And so now we just do the limit. The limit as n approaches infinity of this partial sum is going to just be 1/3 times 1 plus 1/2 plus 1/3. Done. So I suppose we could actually write this out. What's that going to be? 11/6 times 1/3. So 11/18. Is that the right answer, I hope? 5/6 plus 1 is 11/6. Yeah, that looks good. So anyway, that's the sort of thing. Yeah, so this is telescoping, by the way. So I don't know if I have one of these on your actual test. I haven't got your test printed up, mainly because I got distracted yesterday schooling a couple of people in how to play Terraforming Mars correctly. So I actually, do that later. So, took a photo I could show you. But, It was quite a drubbing. So I don't know if that answers the question. Probably does. It's more than you wanted with that one. What else do we need to do with this homework? Oh, we're almost done. What in the world? 10:02. Was there anything that was particularly horrible on the homework other than that one? That one, I admit, that was horrible. Oh, yeah, Maggie. Yeah, let's do 13, and then we're going to have to call it a day. So let's go back to 13. 13. There it is. Okay, yeah. So we're trying to figure out, does this thing converge or diverge? So let's see. We have the sum where n goes from 1 to infinity of n cubed over 5 to the n. Okay, so I need to figure out, does that converge or diverge? N cubed over 5 to the n. Sorry, I got to do this. 1 to infinity n cubed over 5 to the n. Converge or diverge. So as I rack my brain as to what I'm going to do about this, I think, well, maybe I could come up with some sort of direct comparison or limit comparison. This doesn't fit any of the things that I'm used to. But here's something that I could do is I could say, okay, n cubed is going to be smaller than 3 to the n as long as n is greater than 3. I believe that's true. Let me double check. Yeah, that's true. So this is true. As long as n is bigger than 3, you can double check yourself. This is true, by the way, of all, I believe this is, let's see, n squared is less than or equal to 2 to the n because of 2 being, 2 is special. Actually, it's less than 2 to the n as long as n is greater than 2. And n to the fourth, I believe that this is always 4 to the n when n is bigger than 4. So there's a little trick you can use, but let's get back to what we're doing here. So I'm going to just use a direct comparison, so check it out. N cubed over 5 to the n is less than 3 to the n over 5 to the n, as long as n is greater than 3, which we're fine with that. And that is a geometric series that converges. So this is less than a geometric series, so it converges as well. So converge. Yeah, that one's tricky. This one is tricky because you had to kind of pull that out of somewhere. There are other ways of doing that, by the way, but that's just one. I've got a practice test online. I don't know where it came from. What I mean by that is it might be 2 years old. It might be, I know where it came from now. Actually, I do know. Just a sec. I gotta show you this so you don't get scared. Give me a sec. Yeah, I just realized where I pulled that out of. Come on, buddy. So give me a sec. Pull this up here. Someday I'm gonna have to tell you why that picture is there, because some of you are like, "What?" Yeah, I'll explain. Okay, so this one, yes. So that one came from 2020. And the reason I know is because when you click on that, you get this. Because in 2020, I had to come up with something. So they were doing it at home. Everyone was doing it at home. So I had them sign this thing. You're not going to have to sign this because you're going to do it for me here. But the problems are similar enough to what you're going to have on your test. So it's not identical, but you're going to have similar stuff. So you'll recognize all of this. Now, a couple of things to note is that there are, let's see, where is it? I thought I saw something that was beyond what we did. Give me a sec. Integral test. Wait a minute, no, this is a pretty good representation. Integral test. No, this is good. Oh yeah, this is a good one. Yeah, this is a good, yeah. So I was worried that, I think I was looking at another practice test I had that had some stuff that was ratio and root test. You don't have ratio and root test on your exam. It'll be on the next one. But no, this is a pretty good representation. So I hope that the answers are correct, but don't lose your mind. I just pulled this out of my files. Don't lose your mind if these are not, if there's a mistake, but just be aware that they are coronavirus free, so you're all set with that. Anyway, if you do have questions, do stop by tomorrow. If you want, you can be here as early as 7:30 to take this test, because I'll be here giving a test to another class. But anyway, if you need to take it at a different time, come talk to me. I'm going to stop the recording in case someone wants to chat. So have a great